Welcome to another episode of Inside DFINITY. Today, Robert and I are exploring one of the most often asked questions that we get all the time, which is what's the difference between DFINITY and Ethereum? Robert has come up with a total of 10 points in how Ethereum and DFINITY are different. Alright, so we're starting with 4 differences between DFINITY and Ethereum that are not consensus related. Robert afterwards is going to talk about consensus related differences, and I'm going to cover some of the non-consensus related differences. So first difference, internet computer, DFINITY, versus a smart contract platform, Ethereum. Ethereum was one of the first concepts, technologies, products, whatever you want to call it, to introduce the concept of smart contracts, which means not only can you exchange tokens or coins and agree on a shared state about who owns how many coins, but you can also execute simple applications in a decentralized manner. Now, DFINITY goes way beyond that and offers what we call the world computer, which is a lot more capable and powerful when it comes to executing applications and instructions in a decentralized context. Difference number 2, on-chain governance with DFINITY versus off-chain governance with Ethereum. DFINITY launches the blockchain nervous system, which is a built-in on-chain governance system. This means that the network can make decisions on upgrades, parameters, and even individual transactions within itself. It also means updating the whole network at once becomes a lot easier than it is currently in Ethereum, where discussions happen off-chain and decisions need to be made off-chain, and then there's no logical link between that decision and the actual implementation of that decision. This can lead to forks, which obviously can lead to a lot of overhead and a much slower adoption of new features. Third difference, the actor model versus serialized contract execution. In DFINITY, we're allowing you to execute applications on a so-called actor model. So what that means, you have the benefit of both parallel execution of contracts and asynchronous message passing. While on the other hand, in Ethereum, it's a lot slower because everything happens one after the other, and you need to keep a lot of data in your memory, which can be a strain for your machine's memory. Difference number 4, WebAssembly, WASM versus domain-specific languages. So DFINITY is adopting this new standard called WebAssembly. It's a standard that was developed by all the big browser supporters, Microsoft, Mozilla, Apple, and Google. They've built a new virtual machine that allows you to execute bytecode in the browser, which is a lot faster. And so, because all these big browser manufacturers are supporting this standard, our expectation is that there's going to be a ton of tools and a lot of developers that will already know WebAssembly. If you're a web developer and you want to be ready for the future, you're probably already looking into WebAssembly. And the cool thing is, to deploy applications on DFINITY, you won't need any new tool sets, tool chains. You will already have those in place because we're using the same standard. Whereas on Ethereum, they went with domain-specific languages, among them Solidity and Serpent, which are languages that were made just for Ethereum, which could be great, but it also means that you have to learn yet another language in order to develop and deploy applications for Ethereum. And with that, over to Robert.
Difference number 5, proof of stake versus proof of work. Let's start with proof of work because that's a traditional system that's currently in use by Ethereum. Proof of work means that the block makers or miners have to solve crypto puzzles in order to get the right to create a new block. This system has a very high, or leads to very expensive computations and also needs a lot of power. So that's why people came up with a new kind of system called proof of stake, which we at DFINITY are going to use. So what does proof of stake mean? Proof of stake is basically a system where your chance of becoming the next block maker depends on your fraction of stake that you have deposited or that you own in the system. Ethereum will also change to a system called Casper, where they will use both proof of work and proof of stake in a hybrid manner. So they will still keep their proof of work based blockchain as the underlying layer, but they will build a proof of stake system on top of it called Casper, the friendly Finality gadget, which allows Ethereum to finalize blocks by a system that's based on proof of stake. So let's talk about difference number 6, fixed size deposits versus variably-sized deposits. So in DFINITY, the idea is that you have to make a deposit in order to become a miner. The amount of stake that you have to deposit is fixed by the system, which means that if you want to deposit more stake because you have more stake at your disposal, then you will necessarily have to create more than one ID. So the number of IDs will translate into your power that you have in the system. In Ethereum's Casper, there will be variably-sized deposits, so the IDs that you can create in the system can have a different impact on consensus. So that's also the difference between the two systems. Difference number 7. DFINITY favors security over liveness, while Ethereum favors liveness over security. So what does that all mean? Well, in DFINITY we have so-called threshold groups, where groups of 400 IDs are selected by the system randomly to notarize blocks. And we need at least 51% of the members to create their threshold signatures in order to notarize a block and in order to keep the system live. Once that threshold is missed, so when more than 50% of the members drop out or become unavailable, the system will just stop. It cannot make progress, but it can also not be abused to create or forge a new history or to perform a double spend attack. Ethereum takes another approach, still based on proof of work, and proof of work means that the chain that is built by the miners can always make progress no matter how many miners there are. So even if suddenly the fraction or the number of miners or the total hashing power drops to a small fraction of what it was before, the chain can still make progress because blocks can still be appended to it. But once the total hashing power drops, it becomes easier to launch attacks against the chain. So that's why proof of work systems like Ethereum favor liveness over security. Difference number 8. Randomness from a random beacon versus randomness from proof of work or randomness from RANDAO. In DFINITY, we have a system that we call the random beacon. The random beacon is nothing more than a chain of random numbers, where each number is a threshold signature of the preceding one. The fact that these numbers can only be built by a majority of a group of 400 nodes means that the outcome cannot be predicted and can also not be manipulated by any or by a small number of members. This creates a chain of unmanipulable and unpredictable randomness. In proof of work systems, you have a kind of a randomness generator that is automatically available because every proof of work puzzle that you solve can also be regarded or considered as a random value. So there you have randomness for free if you spend enough energy to come up with a solution to the crypto puzzle. Ethereum will finally update their system to Casper, and Casper, being based on proof of stake, needs another kind of randomness or source of randomness, and they are going to use a system called RANDAO, where each node contributes a hash, or the chain of hashes is like an onion where you hash the same value multiple times, and then you can reveal like the layers of the onion one by one. And this allows the system to combine the randomness that's created by multiple people by unlocking the layers of this hash onion. The problem with that approach is that you will always have a last person that will reveal his share last, so this person or ID can influence the outcome by at least 1 bit. Whereas the random beacon in DFINITY is not biasable by any small number of people. Difference number 9. Cryptographic finality versus economic or probabilistic finality. In DFINITY, we have a system where people can decide on their own whether block or the transactions in a block are final or not. They just have to watch the blockchain. Once they have seen that their transaction has been included in a block that has been confirmed at least by one other block, they only need to wait some time, some delay, to be certain that their transaction cannot be reverted any longer. That allows every observer of the system to apply his own level of certainty. If the transaction is very sensitive, you can set the delay higher so that you can be very certain that your transaction won't be undone anytime. Ethereum in its current version is based on proof of work. With every confirmation, a block becomes more certain that it will remain in the chain, that it will remain part of the canonical history. But you can never be sure that a certain block will not get reverted anytime. So with any confirmation you will have a higher trust in the block, but you will never reach 100% security that your block is never going to be reverted. Eventually, Ethereum will switch to Casper, and Casper will provide an economic kind of finality. Now this means that you have people voting on your block, validators voting with their stake on a certain history. Casper offers a kind of economic finality in that if a block gets reverted, so if a block that has been voted on gets reverted, then at least 1/3 of the validators will lose their stakes. That allows to have some kind of certainty that the block that has been voted on won't get reverted anymore, because then a lot of people will lose a lot of money. And finally, difference number 10, finality time. In DFINITY, we have a finality in the order of seconds, while Ethereum will probably offer with Casper a finality after a couple of minutes. DFINITY, as already mentioned in difference number 9, offers finality after 2 blocks and a delay, which is the network traversal time or the network round trip time. This comes down to a few seconds. Ethereum will use Casper to finalize blocks every now and then. They will finalize only every 100th block, where they create like a checkpoint. In general, that allows Ethereum to reach finality after 125 blocks. And with a block time of 2 to 10 seconds, that will amount to like 10 minutes finality.
Alright, so these were the 10 key differences that we found between DFINITY and Ethereum. Just to list them again: internet computer versus smart contract platform, on-chain governance versus off-chain governance, actor model versus serialized contract execution, WebAssembly versus domain-specific languages, proof of stake versus proof of work, fixed size deposits versus variably-sized deposits, security over liveness versus liveness over security, random beacon versus randomness from proof of work, cryptographic finality versus economic finality, and finality time 2 blocks versus 125 blocks. So those were the 10 key benefits that we could have come up with. As always, if you have questions or comments, leave them right below this video. We're looking forward to getting your feedback, and with that, we'll talk to you soon.